Hello, my name is Masheka Lewis. This is my Module 3, Chapter 4, and Chapter 5 presentation. Okay. There we go. So the first question is that the first problem is that we have to see if these numbers at the top are divisible by 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11. And we have to see if they're divisible by using the divisible rule. And after we find out if they're able to, when we find out if they're able to be divisible, we'll have to answer yes or no in the box. So first we have to know what the divisible rules are. So for 2, the last digit had to be even for it to be divisible. 3, you have to add all the digits and then find the sum. If the sum is divisible by 3, then the whole number is divisible by 3. For 4, you have to look at the last 2 digits to see if they're divisible by 4. 5, the last digit had to have a 5 or a 0. 6, the number had to be divisible by 2 and 3 for it to be divisible by 6. 7, take the digits, take last digit and double it, and then you'll subtract it from the rest of the digits. And if that number is divisible by 7, then the rest of the number is divisible by 7. For 8, you'll check the last 3 digits. If so, the whole number is divisible by 8 if the last 3 digits are divisible by 8. For 9, you'll add all the digits. It's just like 3, you'll add all the digits. And then if that number is divisible by 9, then the whole number is divisible by 9. 10, the last number had to be 0. And as for 11, add the odd digits, then you have to add the even digits, then subtract the 2. And if the digit is a multiple of 11, or if it's a multiple of, or if it's 0, then it's divisible by 11. So let's apply these. Let's move this down here for a second. So first, number 2, we have to look at our last digits. Oh, sorry. So we have a 4, 4, 1, 0, and 8. Well, everything is divisible by 2, but 1. So that means everything would be, yes, it's divisible by 2. Now, number 3, you have to add all the digits, and then if the sum is divisible by 3, then the whole number is divisible by 3. So we have 684, we'll add that is 18. And 18 is divisible by 3, so it'll be divisible by 3. The whole number will be divisible by 3. So the answer is yes. Then we have 2,000. Oh, this keeps popping up. Oh my God. We have 2,064. We'll have to add the 2064. Why is my thing just not working? We'll get a 12. When we 12 is divisible by 3, so it's the whole number is divisible by 3. Then we have 51051. That'll be 12. 12 is divisible by 3, so the whole number is divisible by 3. Then we have 64490. That's 27. 27 is divisible by 3, so the whole number is divisible by 3. And then we have a 5025058. That's a lot of numbers. Our sum is 27 as well, and it is divisible by 3. So this whole number is divisible by 3. It is important to keep in mind that for the 6, you know you have to have a 2 and be divisible by 2 and 3. So the only number will not be able to be divisible by 6 would be the middle column, 51,051. Now, as for 4, you have to look at the last 2 digits. If that is divisible by 4, then the whole number is divisible by 4. So 84 is divisible by 4. 64 is divisible by 4. 51 is not divisible by 4. You have 90, which is not divisible by 4. And then you have 28, which is divisible by 4. After 5, the last digit had to be a 0 or a 5. And as we look, we have fours, ones, and eight, which is all not five or zero. So these would three, and this one will not be divisible. But we do have a zero right here, which means this is the only one divisible by five. Oh, no, place not. I think that's better. Now let's go to sit. Like I said, it's the key. It was important to keep track. So like I said, every number was divisible by two and three, but this number was not divisible by two, so which means that it is not divisible by six. Now we have a seven. We'll have to take the last digit, multiply it by two, or basically times two, multiply it by two, which will give us eight. And then we'll subtract it from the rest of the digits, which is 60 for this one. And then we'll have to see if 60 is divisible by 7. If not divisible, then it's a no, and if it is, then it is yes, like this one. You take the 4, you double it, and it'll be an 8. And then you subtract it from the rest of the number. And whatever the sum is, if it's divisible by 8, then the whole number is divisible by 8, and so on, so on. Now 9, you'll have to, oh, sorry. 9, you'll add, it's just like 3, you'll add all the digits. And when you add all the digits, you have to see if that sum is divisible by 9. So we have 18, which is divisible by 9. We have a 12, which is not divisible by 9. We have another 12, which is not divisible by 9. We have a 27, and then we have another 27. So depending on if it's divisible by 9 or not, you have to add it just like 3. If it's divisible by 9, if it's divisible by 9, then the rest of the number is divisible by 9. If it's not, then it was not divisible by 9. I wonder what is up with this. Okay, the rule for 10, you'll have you'll have to have a 0 as the last digit. So as we see, we'll have another 0 but this one, just like 5. So all of these numbers would be 0, would be no, and this would be yes, because it's a 0. Guess I'm going to just have to use this. Now, as for 11, you'll have to add the even digits, then add the odd digits, then subtract it. And if the number is a multiple of 11, it is divisible by 11 if it's a multiple, or if it's a 0. If it's not, it is not divisible by 11. So we have 684. So we'll have to do the 4 and 6, which is a 10. And then we have 8. And then you'll subtract it, which will give us 2. And 2 is not a divisible of 11. And then we'll just keep going. So we have a 0, 4, which equals 4. Then we have a 6 and 2, which equals 8. So 8 minus 4 is 4, and it's not divisible by 11. Then we have a 0, 1, and 5, which is a 6. Then we have another 6 because of 5 and a 1. And then 6 minus 6 is 0, which means this is divisible by 11. Then we have a 4, 4, 0, which is 8. We have a 9, 4, 6, which is 19. And then 19 minus 8 is 11, so it is divisible by 11. And then we have a 8, 5, 5, 0, which is 18. 2, 2, 5, and 0, which is a 9. 18 minus 5, 18 minus 9, is that a 2? It was 2. And then it was not divisible by 11. And that's the divisible rule. Now, for this one, we'll have to demonstrate the use of process of 9 to check if the following answers are correct. So to solve this, you'll have to add the digits just like the multiple of a 3. So you'll add each digit in a set, and then you will not count 9 as the reminder right here. You'll not count the 9. And then you'll add all these digits, and then you will add the sum of those digits, and if they're matched, that means the answer is correct. If they do not match, it is incorrect. And if it's incorrect, you'll have to solve the problem that it gives you. and then get the correct answer. So the first one is A, which is 416 plus 7,490 plus 69,844 is supposed to equal to 100,012 and 790. So, like I said, you add each digit, which will give us 11 for this one. Give us 11 and 11, and then you'll get to your given answer, which is 11. And then the 6, 9, 8, 4, and 4 is 22. Now then, you will not add the 9, so that means it'll only be adding the 4 and 7, and that's how you get the 11. You'll not add the 9 in this row, so you'll only be adding 6, 8, 4, 4, and you'll not be adding the 9 in this row. So then you'll add these digits, which is 11, so you'll have 2. Again, you'll have 2. And then you'll have 4, because 2 plus 2 is 4. And then again, you'll have 2. So then you'll add all of these, and you'll get 8. And of course, we have a 2, so 8 do not match 2, which means we'll have to solve the problem ourselves and get our correct answer, which is 7,750. I really hope I'm recording. I did that last time. Okay. Now we have B, which is 8,550, 6,888, 2,525, 6,029. And our given answer is 23,892. So again, we'll add all the digits separately. We'll get 18, 30, 14, and 8. And then give the given answer, which is 15. So then, remember, we do not add 9s. So we'll not add the 9 in this one and the 9 in this one. So then we'll separate the answer, which is 8 plus 1 is 9. So we'll count this as a 0 because it's a 9. Then we have a 3 and a 0, which is 3. We have a 1 and a 4, which is 5. And then we bring our 8 over. And then we have a 1 and a 5, which is 6. So this is our answer. So then we'll have to add the sum, which is 3, 5, and 8, and 0, of course. So we have a 2-digit because it equals 16. So what we'll do is we'll just separate this again and then add it, which will give us 7. And of course, 7 does not equal 6, which means we'll have to solve our problem again. And our answer will be 23,992. As for C, we'll do the same thing over again. So again, let's separate all the digits, and then we'll add it. We'll separate the digits for this, and then we'll add it, which is 26, 20, and then we'll separate our given answer, which will give us 32. So 2 plus 6 is 8, 2 plus 0 is 2, and 3 plus 2 is 5. Then you'll add the 8 and 2, which will give us 10, but 1 plus 0 is equal to 1, so it will give us 1. And 1 do not equal 5, which means we'll have to solve the problem ourselves. And our correct answer is 74,688. And again, a little reminder to not count 9, but we don't have a 9 on this one. And our last one, we just solved like we just did, which is 337 times 620. It doesn't matter if it's a multiply, subtraction, addition, division, it's still the same. We're just trying to see if this equals the sum to this. So then we'll get 13, then we'll get an 8, and then we'll do our given answer, which will give us 6. So then this will give us 4, and this will give us 8. So add the 4 and 8. This will give us 12, so we'll separate the 12 and get 3. And of course, 3 do not equal 6, so we'll have to multiply our answer ourselves or do our answer ourselves. And it'll give us 208,940. And that's it. Now we have our next question. Our next question is we have to see how many rods or what type of rod would fit in a certain rod. The best way to solve this would be to find the multiples of it. So let's go to the first one. So the first one is what goes in 9. Like I said, it would be easy to find the 9. Of course, the 1 will go in 9 times. 9 will go in 1 time. But then we also have a multiple of 3. 3 times 3 is equals to 9. So 3 rods will go into our 9. Now let's see our sits. Our sits we can do 6 ones or 1 sit. We can also do 3 2 rods or 2 3 rods because 2 times 3 is 6 and 3 times 2 is 6. So these are our rods that will be able to go into sits. Now part C, they want us to find the greatest common multiple. The greatest common multiple is the greatest number that goes into each number, that goes in both numbers. So if we have them side by side like here, we'll see they both have 3 in common. They also have 1 in common, but it's not the least common multiple. If it's the least common multiple, we'll go for the least number, which will be 1. But we're looking for the greatest, which means we'll find the greatest that they both have in common, and they both have in common 3. So 3 will be our greatest common multiple. Now D, E, and F, technically, they want us to combine, They want us to combine the 10 and 8 rod to make an 18 rod. Like I said, it's easy to find the multiples of 18. So we'll have 18. So 1 times 8 is 18, which means the 1 rod and the 18 rod. The new 18 rod will go into the 18 rod. Then we have 2 9 rods or 9 2 rods that will go into our new 18 rods. Or we can do 3 6 rods or 6 3 rods, which will go into 18. They want us to find which rods. So our 1, 2, 3, 6, 9, and 18 rods will each go into 19. And that would be our answer. What if I'm going too fast? Now they want us to demonstrate the use of the method to find least common multiples through part A through C, which were our questions that were given us. So to solve this, we need to know what a prime number is. Prime numbers are numbers that is not divisible by anything but itself, one in itself. So these are our prime numbers. I got a little picture right here: 2, 3, 5, 7, 11, 13, 17, 19, and so on. So we'll factor out our prime numbers, and then we'll find our answers. So these are our numbers that we're looking for, and these are our prime numbers. Now, usually people would do a chart. I like to do the pyramid because the pyramid you can actually see what's going on. So let's continue. So let's start with 48. We'll start with our least common multiple. 2 can go into 48. Yes, it can. It can actually go in there 24 times. But then we'll do another row. How many times can 2 go into 24? And that'll be 12 times. How many times can 2 go into 12? The thing is, we have to keep using 2 or keep using the least multiple until we get not able to divide it by that number again. And then we'll go to the next. So 2 will go into 12 6 times. And 2 times 6 is 3. So that is our multiples for this. So we have 4 2s and 1 3. Now we have 25. 2 will not go into 5, 3 will not go into 5, but 5 will go into 25. Did I say 5? Okay. 2 and 3 will not go into 25, but 5 will go into 25. And 5 will go into 25 5 times. These are both prime numbers, and we cannot divide it no more. So this will be our answer right here. Now 65. How many times can 2 go into 65? None. How many times can 3 go into 65? None. But 5 can go into 65 13 times. And if you look on our chart, 13 is also another prime number. So then we stop. Now, for this problem, you have 4 2s, 1 3, and 3 5, and 1 13. Now, the thing about this is on a row, you have 4 2s. We have the 2's do not share any other 2's on the others, which means the 4 2's will go down. But when we look at our 5's, we see it repeats itself. So when I have a set of 5, you'll cross out 1 and that will become as 1, 5. So technically, our answer will have 2, 5 to the second power because 5 is repeated in both terms. So we'll only count it once because it's repeated once in here. So 1, we could count it as a row, basically. And then we'll have another 5. So our answer will be 5 to the second power instead of 5 to the third power. And then we have a 3, and then we have a 13. So that'll be our answer. Now for this, we do the same thing like we just did this first time. We start at the least common multiple. How many times can 2 go into 40? And that's 20 times. How many times can 2 go into 20, which is 10? 2 will go into 10 times 5 times, and these are both common multiples. Now then we'll go to 12. How many times can 2 go into 12? 6 times. How many times can 2 go into 6? 3 times. And we have all prime numbers, which will mean we'll stop. And then we have 2. How many times can 2 go into 44? We have 22. How many times can 2 go into 22? Which is 11. 11 is a prime number. We stop. Then we have 363. 2 will not go into 363. Neither will 3, 5, 7. But 11 will go into 363. Oh, I'm sorry. Wrong one. 3 will go into 363, so it'll be 121. But 121 will not be able to divide, and only 11 will be able to divide, which means it'll be 3 and 11, 11. Sorry, I got ahead of myself. Now again, we'll do like we did the first time. Go to the first row. We see 2 on the first row, which means we'll count it one time. So all 4 of these will be counted as 1, 2. And then we have go to the second row. This is all of these 2 will be counted as 2. So we have 2 to the second power for right now. And then we have another 2, which means our answer will be 2 to the third power. Then we have a 5 here and no other 5. So it'll be 5 to the first power. Then we have a 3 and another 3, which means it'll be 3 to the first power because it is repeated and each has one of them. So it'll be only 3 to the first power. Then we have 311. 11 is repeated. So it'll only be 11 to the second power. And this is our answer. Let's go to C. 250. Can 250 go with 2? Yes, and that'll be 125. How many times can 2 go into 125? 9. How many times can 3 go into 125? 9. But 5 can go into 125, and it'll go to 25 times. So how many times can 2, 3, or 5? 5 will be able to go, and it'll be able to go 5 times. So now we go 228. We'll start at the least multiple, which is 2, which is 14. 2 divided by 14. Why is it 2? Well, 2 will not be able to go into 14. I don't know why it's a set. Where's my... where is it? Oh, there you go. So this will actually be a 7, if I can draw a correct 7. Okay, we'll just have it as a 7. Okay, now let's go back to the mouse. And then we'll just continue this because 7 is a multiple. Sorry, I'm trying to get rid of my mouse. My annotated. So we got 44 divided by 2, basically, which is 22. How many times can 2 go into 22? 7 times, and 7 is a multiple. So it's a prime number, so we'll just leave it. And then we have 110. So we'll start at 2. We have 55. We have 5 can go into 55 11 times, and they're both prime numbers. Now let's do our prime. I'm going to use my annotated again for this. well, first, leave it up now. Sorry, I'm sorry about this. So we have 2 on the first row, which is 1, count as 1. We also have 2 on this row, which will count as that 1. So that means our 2's will go to the second power. We have 3 5s, and then we have a 5 right here. So this 5 will count out, so that'll be 1. And then we have another 5, and we don't have no more other 5, so it'll be 5 to the second power. We do have a 7, but 7 is also repeated, so the 7 will go to the first power. And we have an 11, which means the 11 will go to the first power. So technically, even though this was a 2, I made it as 2 and it's supposed to be 7. It's, sorry, it's still supposed to be 1. Girl drawing. Now for the 14 and the 84 teeth. What we try to do is find on this is find out how many times it will take for it to go into the exact same spot as in already. So the easiest way to solve this would be to find the multiples of it. So find the multiples of each. Basically find the least common multiple. So find the multiple of 48 and 84. And then whatever number they have in common is how many times it'll take for it to get there. And then we'll have to subtract them to see how many times one would have to go to complete the other. So 48 is 64, 90, sorry, 96, 144, 192, 240, 288, and 336. And then we have 84, which is 168, 252, 336, 420, 504, and 588. Now we see that 336 is in both of them, which means this would be our common multiple. So then we have 1, 2, 3, 4, 5, 6. It takes 6 times for it to go to 366, and it takes 3 times for it to be 84. So then we'll subtract 6 times 3, which equals 3, which means the 84 teeth will have to go 3 more times around to have be in the same exact spot. Now we're on our last question, which is, sorry, I need to move this back. Oh, there's 2. Okay, I'm just going to leave it. And it is to demonstrate a magic square. A magic square, we'll have to find, we will not be able to use the same number again. And we'll have to have the same number equal horizontally and vertically and diagonally. All numbers have to equal the same. So let's start with the magic square. Oh, great. I am not a fan of this. Let's just put it up here. Okay, so we already have a 0 and a 1. It'll be easy to mark them out so you don't repeat to use them. Now let's start with our 0. Now, to find, well, before we start with our 0, we have to find out what is our magic number. So to find our magic number, we'll have to multiply how many rows is vertically and diagonally, which is 3, and then 3. So 3 times 3 is 9. So our magic number is 9. So we had to find the a 9 to equal in each row. So let's go up and down, since I like going up and down. So we have a 0. So what 2 numbers will make 9? Or in this case, negative 9, because with all the negatives, it's easy to know that it's going to be a negative 9 instead of a regular 9. But 9 is still 9 for magic square. It just has to equal the same type of 9, which is negative 9 in this case. So 2 numbers that equals negative 9, which is 7, and we'll mark it out. And then negative 2, and again, we mark it out. So we have this row filled. Now we have a 1. Now all of these are negative, and we have a positive number. So what we need to do is we need to make this row equals a negative 10. So with the plus 1, it will be negative 9. The answer will be negative 9. So we'll make a negative we'll make a negative 10. And that would be negative 4, and mark it out, and a negative 6. And we'll mark out the negative 6. Now, this problem will take trial and error because you might like mess up the numbers, but it just depends. You'll still get the answer if you do it the right. Keep doing it. Now we have negative 10, negative 6, and negative 4 is negative 10 plus 1 is negative 9. Now we have a 0 and a negative 4. So what are we missing for a negative 5? I mean, is a negative 5 to complete the negative 9 in this row. Now we have a negative 7 and a 1. So what are we missing? We're missing a negative 3. And we have negative 1 left, which means this should go in this row. Now, to make sure that this is correct, you can add it diagonally, which is 0, negative 3, and negative 6, which is negative 9. And then negative 4, negative 3, and negative 2, which is negative 9. And then you can just keep doing it. And we know that it's negative 9, which means this magic square is complete. And that's it. Sorry about all the mistakes. Uh, have a nice day.